Next one, we have to understand here electronic distribution. Electronic distribution. Electronic distribution means we discussed middle of atom there is nucleus, around nucleus first orbit, second orbit, third orbit. So in first orbit how many electron, second orbit how many electron will be there. Okay, these things we can predict according to electronic distribution. Okay, scientist Bohr, we learned Bohr model of atom. Same scientist suggested electronic distribution. Scientist Bohr suggested electronic distribution. Okay, to understand electronic distribution, we have to know the equation 2n square. Based on this equation, we can understand here electronic distribution. Okay, so you want to know first orbit. How many electron? To understand how many electron in first orbit, you have to use this equation 2n square. Okay, 2 times 1 square. Here n represent number of orbit. First orbit n equal to 1, second orbit n equal to 2, third orbit n equal to 3, and so on. Now here first orbit n is equal to 1, so 2 times 1 square, so it will be 2. First orbit there will be 2 electron. We want to know second orbit how many electron. So we have to use 2 times 2 square. Second orbit, so 2. We have to use 2. Second orbit 2. Okay. So here 2 times 2 square. 2 square means 4. 4 times 2, 8. So second orbit there will be 8 electron. Similarly third orbit, 2 times n square means 3 square. So 3 square means 9. 9 times 2, it will be 18. So we got here first orbit there will be 2 electron, second orbit there will be 8 electron, third orbit 18 electron. Similarly fourth orbit there will be 32 electron. So we can find number of electrons in different orbit accordingly. Clear? Now see here, based on this we can predict different structure of atom. Okay, so here I told you before periodic table. You can see here this is periodic table. Using this periodic table you can find different type of elements. There are different elements, more than 118 elements. Their symbols are there. Also there is their atomic number and mass number. For example, you can see in this periodic table 612. Here 6, it is atomic number. 6 means it is atomic number. Okay, atomic number 6 means there is 6 electron, there is 6 proton. So we have to use this atomic number. Use atomic number carbon 6. Atomic number of carbon 6 means there is 6 electron. Atomic number of sodium 11 means there is 11 electron. Atomic number of sulfur 16 means there is 16 electron. So use these things. Okay, at least you remember first 20 elements with their atomic number: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, etc. Till 20 you have to remember according to their atomic number. Okay, so using this atomic number we can draw the structure of atom, atomic structure. For example, hydrogen. Draw the structure of hydrogen. So hydrogen, use your periodic table. You can see like this: atomic number of hydrogen 1. So in the middle we know there is nucleus. Around nucleus, first orbit. How many electron here? Only 1 electron. This is the structure of hydrogen. Okay, next one, hydrogen, helium, lithium, beryllium, many elements. So we will choose here beryllium. Hydrogen, helium, lithium, beryllium. Fourth one. So hydrogen, helium, lithium, beryllium. Fourth one. So atomic number 4. So to draw the atomic structure of beryllium, you can do like this. In the middle nucleus, first orbit, second orbit. First orbit we know. First orbit 2, second 8, third 18. Okay, we have only 4 electron. So first orbit 2 electron. Second orbit not 8. We have only 4. Okay, we did already 2. We have only 4 electron. We did first orbit 2 electron. So how many electron will be there? How many electrons left? 4 minus 2. 4 minus 2 means 2 electron. So this is the structure of beryllium. Okay. Similarly, another example, sodium. Sodium atomic number 11. This is atomic number. This is mass number. So atomic number 11 means there is 11 electron. So in the middle of atom there is positively charged nucleus. First orbit, second orbit, third orbit. Okay, so here look here sodium 11, first orbit 2 electron, second orbit 8 electron. Okay, we know second orbit 8, third orbit not 18. Here only 11. We did 2 8, 2 plus 8 10. 11 minus 10 1. Clear? First orbit 2, second orbit 8, third orbit 1, because 11 electrons only. 11 minus 10 1. So we have to do here 2 8 1. You can put this electron anywhere. It doesn't matter. You can put it anywhere in this orbit. Okay, so 2 8 1. This is the atomic structure of sodium. You can do any element this way. And also here you can see there are many elements with their atomic structure. Okay, next one we have to understand here valency. Valency. Okay, valency means combining power of an element called valency. Combining power of an element called valency. Okay. Look here, this is one picture of periodic table. You can see there is group and period. We discuss periodic table, group, vertical column in periodic table called group. There is first group, second group, third group, fourth group, okay, till group 8. Group 1, 2, 3, 4, 5, 6, 7, 8. Okay, group 1, 2, then you have to look there group 3, 4, 5, 6, 7, 8. Clear? So based on this group, we can predict their valency. We did electronic distribution. We did electronic structure, electronic distribution. For example, we did before sodium atomic number 11. It is 281. This is electronic structure. First shell 2 electrons, second shell 8 electron, third shell 1 electron. This is the last shell. Last shell called outer shell. Last shell called outer shell. Outer shell. Okay. So here outer shell 1 electron. Last shell called outer shell. Outer shell there is 1 electron. Okay. So here we can say valence electron. Last shell electrons are called valence electron. Okay. So sodium valence electron 1. Okay. So you know, see this periodic table. There is first group lithium, sodium, potassium, rubidium, cesium, francium. These are group 1. Group 1. When you take all group 1 elements, they have valence electrons 1. This is sodium, first group, valence electron 1. When you take lithium, also group 1, atomic number 3, 2, 1. This is last shell. This is outer shell. Outer shell means last shell. Outer shell electron mean valence electron 1. So these are valence electron. Clear? When you take group 2, here periodic table, you can check periodic table. Beryllium, magnesium, calcium, strontium, barium, these are group 2. All group 2 elements, their valency 2, or their valence electrons are 2. Look here, magnesium, atomic number 12, 282. Magnesium, outer shell, there is 2 electron. There is 2 electrons in outer shell. Clear? So all group 2 elements, they have valence electrons 2. All group 3, you can check group 3. Group 3, example aluminum, it is group 3, 283. You can check all group 3 elements, their outer shell electron will be 3. Group 4, valence electrons 4. Group 5, valence electrons are 5. Group 7 and group 8, accordingly valence electrons 7 and 8. So this is valence electrons. Okay, using this valence electrons, we can find valency. I told you valency means combining. The definition for valency, combining power of an element. One element can react or combine with another element. This power is called valency. Combining power of an element called valency. Clear? Now look here, atoms with the outer shell 1, 2, 3, 4. Their valency will be same. I told you what is valency. Example, sodium, valence. I told you what is valence electron. Example, sodium, atomic number 11, its valence electron 1. Magnesium, valence electron 2. Aluminium, valence electron 3. So atoms with valence electron 1, 2, 3 or 4, their valency will be same. So what is the valency of sodium? 1. What is the valency of lithium? 1. What is the valency of magnesium? 2. What is the valency of beryllium? 2. All group 2 elements, valence electrons are 2, valency 2. All group 3 elements, valence electrons are 3, valency 3. Clear? So here atoms with outer shell 1, 2, 3, 4 valence electron, their valency will be same. Okay. And here atoms with outer shell 5, 6 or 7. For example, nitrogen, atomic number 7. First shell 2 electron, second shell 5, outer shell 5. Okay. So what will be the valency of nitrogen? You have to use this equation 8 minus n. Okay, atoms with valence electrons 5 to 8, we can find their valency using this formula 8 minus n. 8 minus n. Here n means number of valence electron. Example, nitrogen, valence electron 5. So you can find valency 8 minus 5. 8 minus 5, so valency 3. Okay, and another example here, phosphorus, atomic number 15, phosphorus atomic number 15, so 285. So what is the valence electron? Valence electrons are 5. So how can you find valency? 8 minus 5, 3. So valency 3. Another example, chlorine, atomic number 17. 287. So how many valence electrons here? 7 valence electron. So how can you find valency? 8 minus n. N is 7. 8 minus 7, 1. Valency of chlorine 1. Okay. Also you have to remember group 8 elements: helium, neon, argon, krypton, xenon. These are the last group 8. Group 8. This group 8 elements also called zero group elements. 8 group 8. Group 1, 2, 3. You can check here periodic table at the end group 8. Okay, so here last group, these are the helium, neon, argon, krypton, xenon. This is their valency always 0. You can check their valency. They have 8 electron except helium. Helium outer shell 2 electron. This is the second element, hydrogen, helium. Second element, its valence, its outer shell complete. We know first shell 2 electron, helium, atomic number 2, first shell 2 electron. Clear? Its outer shell completed. Okay, rest all elements, they have 8 electrons in outer shell, or you can say they have complete outer shell electron. That's why their valency will be 0. Their valency 0. So remember, last group, group 0 element or group 8 element, they have valency 0. Except these elements, we can find their valency accordingly. Okay, 8 minus n, if they have valence electron 5 to 8. Elements with the outer shell 1 or 2 or 3, 1, 2, 3, 4 outer shell electron, or atom with outer shell electron 1, 2, 3, 4. Their valency will be same. Sodium, valence electron 1, valency 1. Carbon atomic number 6, 2, 4, outer shell 4 electron. So its valency will be 4. So you can find valency accordingly. Okay, I think you understand valency and how to find valency. Clear? You can write the valency of sulfur. Write down the valency of sulfur in comment box. Clear? Next one, we have to discuss here proton number. Proton number, or we have to say atomic number. You can see this type of numbers in periodic table. I told you before, you can see many symbols of elements with their name. Symbols of elements with their name. Also the symbols of elements which consist of 2 numbers. This type, you can see carbon 6, 12. Aluminium, you can see 13 and 27. Also you can see here periodic table, you can see different type of number. Oxygen 8, 16. Carbon 6, 12. Nitrogen 14, 28. Okay, this type of numbers, from these numbers we will get many information. Here I told you here carbon 6, 12. Here this 6 called atomic number, or we have to say proton number. Atomic number or proton number. Proton number mean here number of protons inside carbon, inside the nucleus of carbon, it will be 6. Carbon 6, 12. Here lower number always called atomic number or proton number. Higher number, here 12, higher number, it is mass number. Mass number also called nucleon number. Nucleon number. So in periodic table you can see many symbols with different numbers. Okay, for example aluminium 13 and 27. This lower number 13, it is lower number 13 and 27. 13 lower number, 27 higher number. Okay, this lower number always atomic number. Always atomic number, lower number. Atomic number also called proton number. Proton number. Here carbon atomic number 6 mean this carbon contains 6 electron and 6 proton. Generally number of electron and protons are same. Same number of electron and proton. Okay, that's why here 6 electron, 6 proton. You understand? Similarly here aluminium 13 and 27. So here aluminium which contain 13 electron and 13 proton. Clear? Also here higher number, mass number. mass number also called nucleon number. Mass number also called nucleon number. Okay, nucleon number or mass number mean this is the total number of neutron and proton. Okay, here mass number mean total number of neutron and proton. Neutron and protons are inside nucleus. That's why this number called nucleon number. Okay, so here mass number of carbon 12, mass number of aluminum 27. We have to understand here how to find number of electrons, protons and neutrons from periodic table. You are asked to find number of electrons or protons and neutrons from periodic table. You want to find number of electrons, protons of sodium using periodic table. So how can you find it? Use your periodic table. Using periodic table, you can find the symbols of elements, sodium, Na. Okay, also in periodic table you can see sodium, Na, there is two number 11 and 23. Similarly aluminum 13, 27, oxygen 8, 16, carbon 6, 12, copper 29, 64. You can find these symbols with their atomic number and proton number, atomic number and mass number. We discuss lower number, atomic number, higher number, mass number. Using atomic number and mass number, we can find number of protons, electrons and neutrons. Clear? So see here, sodium, its atomic number, sodium atomic number 11. So I told you before, atomic number 11 mean atomic number, it will be equal to number of electrons and proton. Atomic number 11 mean 11 electron, 11 proton. Okay, so see here, sodium atomic number 11. So 11 electron, 11 proton. Clear? Similarly, aluminium atomic number 13. 13 proton, 13 electron. Similarly, here 6 electron, 6 proton, 29 electron, 29 proton. So we can find very easily number of electron and proton using periodic table. Atomic number equal to number of electron and proton. To find neutron number, look here. Mass number minus atomic number, it will be neutron number. You want to find number of neutron. So 23 minus 11, 12. Here 27 minus 13, 14 neutron for aluminium. Carbon 12 minus 6. Copper 64 minus 29. So here 35 neutron. Clear? So using periodic table you can find number of neutron, proton and electron. Look here, this is mass number. Sodium atomic number 11 and 23. Atomic number, it is equal to number of electron, also number of proton. Clear? And this is mass number, number of neutron plus proton. That is mass number, neutron and proton together. That's why we call this nucleon number. So here I told you 23 minus 11, it is 12. This is number of neutron. 23 mean number of neutron plus proton. Number of neutron plus proton, that is nucleon number, that is mass number. When you deduct this with 11, what is 11? 11 mean number of electron, number of proton. So it is equal to number of protons or electron. So this proton number will be cancel each other and you will get number of neutron. This is number of neutron. So simply when you deduct 23 minus 11, number of neutron. Okay. 64 minus 29, 64 minus 29 for copper, so 35 neutron. So you can find number of neutron this way. Okay, next one we have to discuss here isotopes. Isotopes. See here example for isotope carbon 612, carbon 614. Here same element carbon exists in different form. Here carbon different form of same element. Here this is carbon, this is also carbon, their atomic number same, but they have different mass number. Here mass number 12, here mass number 14. This type of elements, this type of atoms are called isotopes. Different atoms, these are different atoms, but they are same element, they are carbon. They have same proton number, but they have different mass number. These are called isotope. Isotope means different atoms of same element with different mass number called isotope. Okay, these are the isotopes of carbon. And another examples for isotope H11, H12, H13. These are the three different isotopes of hydrogen. Hydrogen shows three different isotopes H11, H12 and H13. These are the three different isotopes of hydrogen. Okay, H11 called protium, deuterium and tritium. These are the three different isotopes of hydrogen. Only one element with no neutron. Only hydrogen, there is no neutron. Look here, H11, number of proton 1. We know hydrogen, atomic number 1. Atomic number 1. So number of electron 1, number of proton 1. But number of neutron, we know how to find number of neutron. Mass number minus atomic number. Only for hydrogen, atomic number and mass number same. Okay, so 1 minus 1. Number of neutron will be 0 for hydrogen. Number of neutron for hydrogen 0 for protium. Okay, generally we will represent hydrogen H11. So only hydrogen atom, there is no neutron. Okay, so isotope, the definition for isotope, different atoms of same element have same number of atomic number but different number of mass number. Okay, so here atomic number same, or you can say proton number same. Atomic number and proton number same for isotope, but neutron number, look here 12 minus 6, neutron 6, 14 minus 6, 8. So number of neutrons will be different, or you have to say number of mass number different, or neutron number different for isotope. Atomic number or proton number same. So for isotope, atomic number or proton number same. Mass number or nucleon number will be different. Clear? This is about isotope. After that, we have to understand here radioactive isotope. Radioactive isotope means some isotopes are not stable. They will not stay same during the time. For example, here carbon 14. Carbon 14, it is radioactive isotope. Radioactive isotope means this isotope, this carbon 14 atom or carbon 14 isotope, it emit radiation. It emit harmful radiation. Harmful radiation we will call alpha, beta and gamma. Alpha radiation, alpha, beta, gamma, these are harmful radiations emitted by radioactive isotope. After emitting harmful radiation, this isotope will change to another atom. This atom, this nucleus will change to another nucleus. Such type of isotopes are called radioactive isotope. So radioactive isotopes are not stable. It emit harmful radiations, alpha, beta and gamma radiation. After emitting harmful radiation, this radioactive isotope changes to another isotope. Okay, this element will change to another element. Such type of isotopes are called radioactive isotope. Okay, and here we have to understand radioactive isotope. We will use this. We have different uses for radioactive isotope. Radioactive isotope used for cancer treatment. Okay, the radioactive isotope of cobalt 60. Here CO mean cobalt. Okay, and the mass number is 60. Cobalt 60 used for treatment of cancer. For cancer treatment we will use cobalt 60. And another one, carbon 14. We can detect age of fossil fuels. You can see here one figure, here dead bodies or fossils or dead remains of plants or animals. We can detect the age of this living things, how long it before, using this carbon 14. This process is called carbon dating. Carbon dating. Okay, so here cobalt 60 cancer treatment, carbon 14 used for carbon dating. Carbon dating. Okay, and another one, uranium 235. Uranium 235, another radioactive isotope. Uranium 235, it used as nuclear fuel. Okay, so here nuclear fuel. You can see this figure here, this nuclear reaction. Here in this nuclear reactor, there are many chemical reactions like nuclear fission. Okay, and it produces large amount of energy and we can utilize this energy. Okay, so this is nuclear reactor. So in nuclear reactor we will use uranium 235. Okay, also another radioactive isotope, iodine 131. Iodine 131, this is another radioactive isotope, iodine 131. This one used for treatment of thyroid gland. Treatment of thyroid gland. So these are the different uses of radioactive isotopes. Clear? Okay, we discussed isotopes and different uses of isotope. We know one element exists in different form, in pure form. One element, but it exists in different pure form. For example, chlorine. There are different isotopes for chlorine. Chlorine 35, chlorine 37. Okay, but in our periodic table we can see only one element, only one chlorine. We cannot see chlorine 35, we cannot see chlorine 37. One chlorine with one atomic mass. Okay, so this atomic mass is called average atomic mass. Average atomic mass. Chlorine 35, chlorine 37. Using this we can find average atomic mass. So how to find average atomic mass? Look here, one question here. Chlorine exists in chlorine 35 and chlorine 37. Chlorine 35 means chlorine with atomic mass 35. Chlorine with atomic mass 37. The ratio of these elements are 3:1. Chlorine 35, it is 3 and 1. This is the ratio of this isotopes. Using this ratio and this atomic mass, we can find average atomic mass. Look here. I did here 35 times 3 plus 37 times 1 divided by 1 plus 3. This is I did here 35 times 3. Here chlorine 35, it exists 3. Chlorine 37, it exists 1. This is the ratio of this element exists in the nature. Okay, so 35 times 3 plus 37 times 1 divided by 1 plus 3. Okay, so its answer is 35.5. So you can see atomic mass of chlorine 35.5. This is average atomic mass. This average atomic mass we can find accordingly. Clear? So if you have ratio like 3:1 ratio, you can find atomic mass using this method. Sometimes you have the percentage of these elements exist. For example, chlorine 35, chlorine 37, their percentage of this element exists in the nature 75 percentage and 25 percentage. Chlorine 35, it exists 75 percentage of chlorine, it is chlorine 35. 25 percentage of chlorine, it is 37. So using this percentage, we can find average atomic mass. Same method we have to do here. 35 times 75 plus 37 times 25. This is I did here. 35 times 75 plus 37 times 25 divided by 75 plus 25, 100. Also its answer will be same like this, 35.5. So using this method you can find average atomic mass of any element using ratio, also using percentage. You can find average atomic mass. Okay, here last point from this chapter we have to discuss here isobar. Isobar means different atoms of different elements have same mass number. Mass number will be same but atomic number different. This type of elements, this type of atoms are called isobar. Isotope we already learnt. After this we have to discuss here isobar. You know isotope, same atomic number, different mass number. Also they are same element, chlorine 37, chlorine 35, same element. But isobar means not same element, they are different elements. Argon and calcium, they are different elements, but they have same mass number, proton number or atomic number different. This type of elements, this type of atoms are called isobar. Clear? So these are the things we have to discuss about isobar, and these are the things we have to discuss here in this chapter. Clear? So thank you for watching this channel. Okay, see you. Thank you for watching this channel. Please subscribe and press the bell icon for more videos. Thank you.